Hi everyone, welcome back to our channel Open Knowledge Share. So today in this Python Programming 2022 series, let's discuss about NumPy. NumPy is a scientific library in Python which allows us to save our data in an array format, and it can be like multi-dimensional array as well. NumPy is a base for most of the advanced Python libraries like matplotlib and scikit-learn and so on. So for all these, NumPy is a base on top of it which they have made more advancements. NumPy would allow us to save our data in multiple dimensions and handle it at each dimension. So in this screen, you could see one-dimensional array. There is only one axis. It was just an horizontal axis. NumPy represents each of the axes with the numbers like 1, 0, 1, 2, 3, so on. So, and this is an 1D array. So it has only data in axis 0. And similarly, when you come to the two-dimensional array, so where there would the data can be stored in two dimensions, axis 0 and axis 1. So here this is just like a square or a rectangle. So where you have both length and breadth, likewise there is axis 0 and axis 1, where you can save data in these two dimensions. Similarly, adding one more dimension to a three-dimensional array, this is similar to something like a Rubik's cube or like any box or something. So where it is a three-dimensional structure, so where you will have like three different dimensions, so length, breadth and width. So when here we have axis 0, 1 and 2, and you can save the data in all the dimensions. You have like length, breadth and width as well. In a three-dimensional space, you can save your data. Similarly, it's not just limited to three-dimensional. We can also save our data in a four-dimensional array, five-dimensional, so on. But just that we can't visualize more than three-dimensional array for representing it. So it was showing only three-dimensional, but we can store our data in multiple dimensions. And also we can see the shape of it. Here there are four elements in one dimension, and we see that shape is 4. Similarly, in a two-dimensional array, axis 0, what is the length? Axis 0, there are 2, so 2 here, and axis 1, there are 3 elements, so 3 here. Similarly, in a 3D, you have axis 0, 1 and 2. So axis 0, there are 4 elements. So axis 1, it is 3 is the length, and axis 2, the length is 2. So it came 4, 3, 2. So this way we could represent the shape of the array. NumPy is basically a numerical Python. This library we can import by using import NumPy. Instead of writing NumPy every time, take it as NP. We can just use NP dot and use the functions instead of using NumPy dot. So after importing NumPy, let's try to create an array using NumPy. So for creating an array, we have to use NP dot array, and inside that you can define the data. In case if your entire data is integers or float, or is it the same type of numbers, so then it is preferred to use arrays or NumPy arrays instead of list, because where Python stores the data when it is list compared to when it is array is more efficient. It is recommended in case if you have a numerical data, then it would be better if you store it in a NumPy array instead of a list. So it would be faster as well. We would like to know the shape of your NumPy array, because this is a single dimensional array which we have defined. So let's see the shape first. So shape would come as 3. So now if in case we would like to append the data to the existing array, so we have to use np.append and then a comma and a new element 4. Let's see. See, you can see it has been appended. You can see although it is appended, it is not stored in the A, but because you can see A remained unchanged. So although you have unappend np.append and you had that new element, so you have to again save it back to A. Only then it would be saved in A. So 2D array, you have to give it in here we have given it one single list, right? The same way you have to give it in 2 lists, so one after the other. Let me give 4, 5, 6. you can see it has come in like two-dimensional matrix. Let's see a shape now. It's 2, 3. It means axis 0 has 2 length. So axis 0 is this has 2 length, and axis 1, which is like length is 3. So which means this is 3. So but like in case if you give length of A, it would give 2. That's the reason like we have to use dot shape for it, or else like it would only give the axis 0's length in case if you do length. Similarly, we can define like a 3-dimensional, 4-dimensional and so on, just by giving like one top of like one more list of lists like that. So instead of that, in case if you want to generate a random values given the shape, so we will be able to do it using NumPy. First, let's try to generate all zeros data. So let's say 3, 4 in bracket. So if you give, it would generate a matrix array, 2-dimensional array with shape 3, 4. I mean like axis 0 is 3 and axis 1 is 4. Or instead of all zeros, you can also generate all ones. Let me give like 5, 2. There are like 5 elements in length is 5 in like axis 0 and length is 2 in like axis 1. If you would like to generate an array with a random samples, so we can do it by np.random.rand, and we give the shape of the array which you need, so it would generate it. So this time I would like to give a 3-dimensional 2, 4, 6. So it would generate 3-dimensional array, but when you print it, it would come this way. So where this is axis 0 is like axis 0 has 2 elements and axis 1 has 4 elements. So 1, 2, 3, 4, right? So and this is like 4 elements is for axis 1, and similarly axis 2 there are 6 elements. So 1, 2, 3, 4, 5 and 6. If you give like 4-dimensional values here, so this is like shape of 4 dimension, it would be represented like this, but you can see there is a difference of lists, right? So it would be list of lists like that. So that way you can see there is a difference, but it would be a 4-dimensional array. This is like axis 0, which is like having 2 elements, and then there are 4 in the rest, which is these 4 for each axis zeros. So and this is like this, and then 6, which was 1, 2, 3, 4, 5 and 6, and similarly there are 3 in axis 3, which is 1, 2, 3. That is how we can generate multi-dimensional arrays. Let's discuss about like few functionalities within NumPy. There is NumPy.Arrange. It is similar to range function in Python. So where if you give like a range of 10, so it would give like values from 0 to 9, right? The same way even here, if you give like a range of np.arrange of 10, so it would give like 0 to 9. In case if you specify 2, it would be treated as start and end. So you have like it starts from 10 and ends at 19, the same way like how the range function works in Python. If we want to generate a multi-dimensional out of it, so we can do a reshape. Here there are how many? 10 elements. So 10, maybe I want to make it like 5, 2. 5 is a length in axis 0. Axis 1 is 2. Here 10 elements we gave 5, 2. But in case if you give 5, 3, which actually expects a 15 elements, right? Because 5 into 2, 3, 5 into 3, which is 15. But here there are only 10 elements. So let's see what it would do. It should give an error because it is unable to reshape a size of 10 into 5 into 3. Let's say you want 5 rows every time, but it doesn't matter like how many columns you need. So then you can just keep -1. If it is okay, it can be any, but you are strict that like you need like 5 in axis 0. So then you can give -1. It would automatically arrange. I give it like 40 here. Okay, then there are like 30 rows. So it would automatically 0 is like taken as 5, and the rest like it would arrange such that like it is axis 1. So I'm taking like 2 arrays like of equal dimension. I want to do a subtraction. Will this work? Let's see. It seems like it is working. You can see like 1 minus 43, which was minus 42. 2 minus 15 which is minus 13, and 3 minus 26 is minus 20. It would take element wise subtraction. So similarly, addition would also work. A plus B, if you take it works. Similarly, let's try to do A into B and see if it works. Yeah, even A into B, it has multiplied a corresponding element in the position, like 43 into 1, and its value is here. 15 into 2, it is 30, and similarly like 26 into 3, which was 78. So even multiplication can be done. I think the division would also be possible. So let me do that. Yes, division is also possible. It is like 1 by 43, 2 by 15, and then 3 by 26. We can do all these arithmetical operations. Both the arrays should be of same dimension. Only then like we can do this, or else like it would throw an error. Let me take like one 2-dimensional array. So I would take it using this np.random instead of me directly giving. And so let me take like 2 random vectors. Always it wouldn't give like same if you do randomly. This first matrix is A, like, and is different from the second matrix. So because every time you call for a random, it would generate a different integers or like decimals values. In these matrix, like in case if we want to do matrix multiplication, instead of here we have done direct element wise multiplication, but in case if we want to do matrix multiplication with this row to this column, then this row to second column, this row to first column, and again second row to second column. So that is how like matrix multiplication usually works. In case if we want to do that, A dot B, so this would do that matrix multiplication. So if it is 2 by 2 matrix, both are 2 by 2 matrix, here the output would also be 2 by 2 matrix. We can do math operations, few more math operations like np dot square root. Square root of A, like it has applied for square root in each of the elements. So 1 square root is 1, square root of 2 is 1.44, square root of 3 is 1.732. Earlier we used to use math dot square root and apply it on each element separately, but it would automatically apply it on all elements within an array. So that is an advantage here. Now we can also do like sum, so which of the elements, which is like dot sum. Similarly, like in case we want to know the minimum value, you can do like A dot min, which will get, similarly A dot max will give us the maximum value. You can also sum across a certain axis as well. I've taken a 3 by 4 matrix. If you do like A dot sum, it would sum all the values. But in case if you specify axis equal to 0, it is summing across axis 0. So at this level, so all the values, so all these 3 would be summed, and this is a value you get. Similarly, all these 3 would be summed and you get this value. Likewise, you are getting single dimensional array with the shape of 4. Axis equal to 1, if you do, it would sum over the axis 1, and you would be getting a single value, and some of these, and you would be getting one more value, and some of these you would be getting one more value here. Even if it is a 3-dimensional, we can still do the same. So let me take a sample of a 3-dimensional array. See, you can see it has summed across axis 0. So actual A would be like this. So actual A, like axis 0 has 3 metrics, right? So these 3 metrics are summed, I mean these 3 arrays are like summed to each other, and we'd be getting one single like this, because like these 2 will be merged to this like and are summed. So, and you would be getting one single 4 by 5 array, which would be 2-dimensional. Similarly, you can use axis equal to 1 and get a 3, 5 array, and similarly axis equal to 3, it would be 3, 4 array. Similarly, not just sum, there is also like cumulative sum. Let me show it with a smaller example. So I have taken like array A as like 1, 2, 3, 4, 5, 6, 7, and now if you do cumulative sum, it would actually sum like, let's say like initial value would be the same, so 1, and the second value would be sum of the first 2. So 1 plus 2 is 3, and the third value would be like sum of first 3, which is 1, 2, 3, which is 6. Similarly, fourth is like 1, 2, 3, 4, which is 10. Similarly, fifth is like 1, 2, 3, 4, 5, which is 15. So likewise, it would actually accumulate the sum and add to the new number and give it. Even this, you can specify the axis and sum it only upon that axis. We can use exponential math function, how we have used the same way. We can use the same here. Here, this is like e power 1, e power 2, e power 3, so on. So those are the values over here. So you can see it is being increased like exponentially. So e square, e cube, like that. Let's say you have this two-dimensional array, and this one you would like to, instead of a two-dimensional, you would like to keep it in a single dimension. So which like one way would be doing reshape and change it to a single dimension. So here it is 5 into 4, it should be reshaped to 20. So you would get it entirely in a single dimension, right? So this is how we can change it to a single dimension. Or else like every time it would be difficult, because like there can be a chance that your value shape would change dynamically and you can't every time change it, right? So you can just give -1 and it would whatever the value here, so it would automatically reshape it accordingly, because it is a single dimension, so it would just like flatten all the things. So if you do a dot flatten, it would do the same thing what this dot reshape of -1 has done. Like let's say I have taken dimensional array and reshape, it is a 3-dimensional array. So if it do a flatten, it would keep like all in a single. So even reshape of 1 would also do the same. So you get the same values. Let me take only 2-dimensional for easier purpose. I've taken A as a 2-dimensional array, and you can do transpose, which is also one of the popular matrix operation. So where like your rows will go as columns and columns will go as rows. So and you can see like there are like 4 in axis 0 and 5 in axis 5. Like it has changed it to 5 in axis 0 and 4 in axis 1. Like means dot shape would interchange. Even if you take like a 3-dimensional, I'll give only shape, like not seeing it. If I want to do transpose, if you do a transpose, it would change it completely. 3, 4, 5 is the previous shape, it is reversed. Like as if you would like to resize your array to some other dimension, so let's use np.resize, and if we give it is previously it is 3, 4, 5 is the shape, so I want to make it 2, 3, 1 as a new shape. And you can see like if you see the dot shape, it came as like 2, 3, 1. But if you use reshape, like it would give an error. So that is a difference of a dot reshape, and if you do 2, 3, 1, so it would throw an error. So it would say like previously it was of shape 3, 4, 5, which were like containing 60 elements in total. So it can't be reshaped to 2, 3, 1. 2, 3, 1 actually needs 6 elements, right? So 2 into 3 into 1. So but it can't be done because it only tries to do reshape. But when it comes to resize, so it can convert your data, like it will try to approximate or like take an average value, or it would resize the array as per the required shape. So it can be any shape, like you can even increase the shape to 10, 3, 1, so which is again 30. Let me do more as well. I mean, here there are like 60 elements. Let me give, if it is 6, 1, like it is just like reshape. But I would also do something like 10, it means it needs 100 elements in total. So I'm doing it like that, still it would be do it. So this way, like what it would try to do is try to extrapolate the values. So let me take a equal to, I would do np.resize and give a comma 2 by 2 matrix. Let's say I want to resize it to 2 by 2. Just with a single value. You see it has extrapolated this 10 even to the next values. Let me now do 10 comma 20 and reshape it to 2 by 2. It would see like 10, 20, or maybe now I'll do 4 and 3. You can see it has extrapolated into 4 comma 3 rows by this way. This is very useful functionality, mainly in case of images, when you are dealing with images where it is a 2-dimensional or 3-dimensional data, and you would like to resize your image into a smaller or maybe a larger one. So it would be able to do it by using np.resize. So now let's see about like indexing in NumPy. Let me take A as a NumPy array like of this format. So you can have to access elements within the array. Like you can use it similar to a list, like where let's say I want to get the element here which was in index 0, 1, 2, second position. You can do it like A of 2, because this is a one-dimensional vector, one-dimensional array. So in case if you would like to access from second element till last, like you can give like this 2 is 2, and then if you don't specify, it will come till end. So if you specify -1, it would till last but one element. Let me take a 4, 3 array, do a indexing here. If I do A of 0, instead of a single value here, it would give like the entire row, so which was this. So it would take like access 0 as 0, and in that like whatever elements are available, like it would return you those. So which would be like these 3 elements here. So similarly A of 1, A of 2, it would let me do like A of 2. So A of 2 would return as this element. In case if you would like to access the element here, only this element which was like a 0, 1, first row and first column. So A of 1, 1. So A of 1 is also a way of accessing it, like this one. If you would like to access the first column, so you give comma 1, so which means you take like all values like which are in axis 0, there is no restriction, but in axis 1 you would like to only look at the first index. So if you run this, you see like it has given us this column values. So similarly, if you would like to access this column values, it is A is to 2. Let me take a larger values here. 8 elements in each in axis 1, like there are like 6 such, so which is axis 0. So I would like to get only few of them, like not continuous columns. So instead, let's say like I would like to get like first to third columns, and in the rows, and then this column wise I would like to get like second to 5. And if I run it, so I would be getting the first and second like index 1 and index 2, these values, these as an axis here, and but it in the column axis 1, it is like 2 to 5. 2 is like 0, 1, 2 till 5, 3, 4. It would return as here to here, and again like here to here. Let's say if you'd like to have only certain column values, let's say like 1 comma like 4 rows of like only in the first row and the fourth row, and again like you would like to have only column 2 value, like let's say column 3 value. If you run it, so row 1 is this. So in row 1, third column, which is like 0, 1, 2, 3, which was 0.43, which was here. And similarly in the fourth row, 1, 2, 3, 4. In the fourth row, if I would like to have the third 0, 1, 2, 3, so which was this, it would return that. So similarly, like you can do it for like a higher dimensional matrix. And in case if you would like to extend a row again to this, I mean increase the shape to it. Let's say you have a single dimensional array, but if you would like to extend it to a new axis, so you can do it like this, comma np dot new axis. This would, you can see there is a difference in how it has given. So let's see the shape of this. So you can see 3 comma 1, it has added a new axis at this level, because like this is the previous like what is already available, and here it has added a new axis. And similarly, even for like if you would like to add a new dimension at some position, not just at the last axis, and you would like to insert some axis in somewhere in the middle or like in some place, so it can be done by having this np dot new axis. Let's say this is the shape of array you already have, and you would like to add a new axis at some level here. Okay, so after the 2, so the dimension, like it would add one more dimension where you can see dot shape, then you can see 2 1 3 4. If you add the same like here, it has changed and it has come over here. So this way you could add a new access to it. So NumPy has like one more functionality, conditionally like filter like some of the values from the array, like we can do using like np.where. Here I would like to apply a filtering to get only the values which were greater than 0.5, let's say. So np.where of a greater than 0.5. So this is way we can filter out the values by applying some condition. So if you run, so it has given like 0 1 3 4. So 0 1 2 3 4. So these are the indices of the array like which has satisfied this condition. So okay, now you got the indices. So how would we get the actual values instead of the indices? So basically this is index, so you can save it in some value. So I have saved it in as an index value in a variable. So here, and now in case if I would like to access what are the values inside that index, so we can give it like this. So it would give us the actual values. Now let's see about like stacking. So let's say you have like few arrays and you would like to stack like one array upon another. It can be of different dimensions. Say you have array like of shape like 2, 3, and this one to this like you would like to add one more row. Let's say here 3 elements. Similarly, you would like to add 3 more elements at the down. So for that you should be appending values to the axis here. Vstack of a comma. Now if you would like to run a vstack on this np.vstack and run it, you can see this is what we expect, right? So it has added a new row to it, and now the shape of this new one would be, so let me save it in B. It would be 3, 3, because like previously it is 2, 3, and now one more element has been added in the axis 0, so because of which it has been like 3, 3 now. So similarly this is vstack where you are appending here. Similarly there is hstack where you do that as well, np.hstack, and you would like to add like value at this level. So these two should be in brackets again. And now if you try this, see it has given an error. So this is because the concatenation like previously it is in 2, 3, right, like the shape, even if the new value is getting concatenated to this, so it should also be of the form similar to this, which is like 2, 3 here, like similarly 2, 1 should be there, so that we can add to that. Dot reshape to the 2, 1 and then add it. So then it has been added. So it's not just like, just to avoid confusion, let me give 10, 20 is this, and you are adding, and this has been added here newly. In case if you'd like to stack like 2 different shapes, let's say your B, as of now B dot shape is 3, 3. Let me see C dot shape, which was 2, 4. In case if you are trying to concat this let's say hstack of B and C, you would certainly receive an error, because like it is difficult, I mean it's not possible to concatenate well of different shapes, because here it expects 3 columns or like 3 rows at least. So but there is no common here. There are like 2 rows and 2 in like axis 0 and 4 in axis 1, so which can't be combined. Its shape is having a mismatch, so it is not possible to stack different sizes. So there should be some commonality between them. So it can be used not just for a single column or single row. You can even use a multiple rows. Let's say, let me use this 3, let's say this is A, and let me take one more vector of same shape ones of 5 comma 3. If you would like to concat this one below the other, so we can use np dot hstack. You see this, so you can see hstack would append it, like add it in this horizontal case like here, and similarly vstack would, so it would add it here like in axis 0. So let's say you have 3 comma 2, and similarly b you have same size but once, just to differentiate between them. Okay, so to this, in case if you are doing this np dot hstack of a comma b, you can see for each of them it has added. So after this, like these are added, after this these are added, so same way like how it used to be there. So in that axis it has added this new value. If it is like np dot vstack, see like all zeros at once, and then like we got like ones in the. So apart from this, there are like few basic functionalities within NaN, like within NumPy, which can be used, like in case we would like to represent NaN values, .nan, which you can use to represent NaN values within the array or like even in your data. And similarly, if the, would like to like represent the infinite value, there is this np dot infinite, so which you can use it for infinite value to represent an infinite value. And similarly, if it is minus infinity, we use the same, just like to multiply by -1 to it. So that would be minus infinity. So this is useful in some cases. And similarly, there are various functionalities like sine, cosine, like trigonometric functionalities, and many other functionalities which were available, so which you can use it and explore. So let me do dir of np. So it would list down all the various functionalities that are available here, cases where a NumPy will be useful. So these are, I have discussed about like few of them, but in case if you need, you can refer the NumPy website for it, and then check its manual. Like for every version new release, like this would be updated, and you can find all the information over here. So here let's say user guide, there is this tutorials where you can see the new one, or even for certain cases, let's say you have some doubt in like np.where, so you search for np.where. In this documentation it will be available. So what is the syntax, and what are the different inputs it needs, like in the arguments, and what it does it return, and also the sample like of its usage. So those are available, so you can use it and then explore it.